You hit that back there. Okay, do you guys have your tests?
Yeah, we already grabbed them.
Okay, and then make sure you grab one for the if at the end, the group test. Our tests are right here, so you guys can get to work. And then when you turn them in, can you guys write down the time that you finished so that I can keep track of how long the test took?
Yeah.
You can use your computers, books. Can't phone a friend.
I'm going to go grab the questions.
Okay.
Yeah, you can use it on your phone. Oh, yeah. It says which is not true.
So it might not go there. And, okay.
What do you mean here?
No matter what you do.
Did you graph it?
No.
Try graphing it. That might help you.
You have to graphing calculator.
Do you have your phone? You could use Desmos.
It doesn't work.
Do you want to use Desmos?
Sure.
Okay, here it is. Go for it. Did that work?
And still have the same question.
Okay, what's the question?
Alright, so it's not always at 0, 0. So this
Okay,
right
one of
also.
the things if P is odd, is that it has, they didn't say it, but it's always positive. They should have said that. So if you take this one out,
Yeah.
okay? But is that what you meant when you said that, right? That if it's R0 or greater.
That's for this one, for that one, I think.
Okay, yeah, it's got to be positive. Well, and 0 is not an odd number.
Oh, but -3.
Right. That's right. Yeah, they say positive values because in that section we said that you can't raise anything to a negative power because it only works out sometimes. Like for instance, if this would be -3.3, how are you going to graph -3.3? Because the computer doesn't know, or the function doesn't know, is that an even number or an odd number, because I can only raise even numbers to that power. So if this would have been, let's say 3, well, I guess it could be odd, because odd is yep, okay. When Laura gets back, you guys can go over to the computer lab. I'll open it for you. You can start. You guys are all done. You can go over there right now and start working on your test. Is there anybody still working on their test there in Menominee?
Nope.
Okay, we have to wait here because we got a couple people that are still working before you guys can start. I have to open it for you guys, though. And then once I do, you can open it for Nicole.
That's because they're I don't want to start my day. 9 o'clock. It's not too early. Passed it easily. Shall we?
Yeah, let's do this.
I'm assuming you guys are usually like,
Oh yeah, I got that.
I met Laura on the way over there. She wants her phone and her calculator and her pencil. And then, well, is that her phone?
Yeah.
She just wants her tools. So, and then 222. So it's over, around the corner, over, and then straight ahead. Sure. Oh, that's it. That's her class. Oh, she must have just forgotten to return it. Okay. Did you guys hear that? 222. Yeah. Okay, Jess. Fellas, did you find a test there?
Yeah.
Yeah, we're good.
Okay. Jess is coming.
Okay.
All right.
So what did you guys get for that one? The first one?
B.
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 A.
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 Shit.
I can't remember what I got.
Then it's gonna be.
I think it was B.
Yeah,
Just before you scratch anymore, the reason why A is chosen is you're right. It is the steepest slope, but notice it's the steepest slope going downhill, okay?
Oh.
So you want the shallowest downhill slope, right? Because you want the least negative number.
But it's asking what's the largest average rate of change on the
I know, and that's the part that...
But it's not-
what you're
it's not-
thinking is, what's the largest absolute value rate of change? If
Yeah,
you
but it's-
look, a -4 rate of change is smaller than a -0.5 rate of change.
Oh yeah, I guess you're right.
You
Whatever.
see what I mean? Does that make sense? Because
Yeah.
it's a kind of a tricky question, but it's part of what is true about about exponential functions. Is that if your exponential function goes like this, the slope function goes like this, because it gradually gets closer and closer to 0. So that's why your answer is wrong. It is the most popular wrong choice because you're thinking which one is the biggest slope, but it's the biggest downhill slope, which is the smallest rate of change. It's a trick question. I'll admit it.
B. We're going.
Wait, is that what we're going
No,
with? It's not B. What did you say it was, Jess?
Yeah, it's.
I
Gonna
put B.
Okay.
It's gonna be.
Just wait.
D was basically a flat line.
That's
Which
what,
one would be a flat line?
that's what we're looking for.
Well,
Oh, then it would be D.
Graphic.
I have it on Desmos right now.
I know, and Jess is going to put it up there right now, too. What is
This is a
it?
dumb question overall, and I'm stating
Y
that out to you
equals 10 divided by X.
So it'll be 10.
The slope from 11 to 12,
now. It's not to 12.
It's 10 to 11.
10 to 11 is from here to here. The
So
slope from 10 to 10.5 is here to
It's
here.
from 10.5
Just make sure you
to-
understand which one of those two is less negative, or closer to 0, I should say.
10.5 to 11. Yes.
Yeah.
10 to 11,
10.5
to 11.
10.5 to 11.
Okay.
This is the
So
farthest
C?
one out.
Oops, can you? Yeah, you have to click
Oh,
that. To,
I
that's
don't
okay.
know what I'm clicking.
That's okay. There you go.
So C then?
Yep.
I guess.
No. But
That's why I said it's 10 to 11 is the correct answer. Because it's the one that is the steepest or the least steep as you go along. Closest to 0.
all right, number 3, I put A.
I did as well.
That's what I had.
So A then?
Yep.
Yep. And then question 4.
B. And mine as well.
And then 5.
It's D.
I really don't know, I guess, on this one.
6, I graphed 6.
Okay.
And so, like, the highest point of that vertex was B.
Yeah.
Okay.
So,
Yep.
put C for this one.
Yep. C.
D?
C.
Oh, C.
Yeah.
Okay. Glad I made sure.
Okay, so 8, I wasn't sure on B or D, but I ended up going with D.
Let me graph it quick, just because because after 3, I feel like these questions are made to fool us.
What did you put, Jess?
I think I put D.
All right. So increasing the fastest. 2.9, 3, 2. Yeah, it's D. Yeah, because it wants increasing the fastest.
Yep. So that was right.
Sweet.
And then 9. I think I put A.
A as
Yeah.
well.
For 10, I actually graphed it to get the right answer
Okay.
and, like, matched up the correct graph, so I put A.
Okay.
It's A.
But I wasn't sure how to do that one.
Oh yeah, because so for the square root of x to the power of 5, so square root is just like if you could put a 2 out in front and it'd be the same thing.
Oh, okay.
And so that would be equivalent to 5 divided 2 power wise. And so it's, you just move the exponent over the x up and divide by the exponent on the outside.
Oh,
With
okay.
the number on the outside.
11, I put C.
That as well.
Okay. 12.
I had B for this because it's the only one that didn't make sense.
Yeah, that's what I put too.
C.
Yeah,
C.
13's definitely C. Yeah, B for
I had D.
I
Yeah.
also had D.
Yeah.
We're just good.
For 15, I had D.
Which
D.
one?
I had D.
D is the dog.
It's A.
Because if you factor it out,
Yeah.
the bottom is x plus 1 and x minus 4.
Oh.
And you
No.
take the opposite of the root.
Maybe I did put A. I know the negative too. So you want to put A?
Yeah.
You can go with a
16. It is moving towards 0.
I wasn't sure with this one.
Mr. Hulky, are you in the room?
He's not.
Ah, dang it. I'm in astronomy, so I want to teach him that we aren't actually weightless in space.
17, like I didn't understand the question other than like basically what was the domain.
Well, the answer can't be 0.
Right, the other two don't make sense.
Yeah, so it has to be D.
Which one?
D.
What'd you have, Jess?
I didn't understand it, so my answer probably isn't even right. So I'll just go with D.
No?
I think I put C.
Okay, go with that.
Nice.
Okay. So C was right.
Oh.
18, I put D.
Yeah, I had D as well.
19.
C.
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 Yep.
Yeah, too long, right?
Are we supposed to self-grade?
You're supposed to go through.
Should maybe you could do that first.
If there's an extra period too. No, this is a review. This is a review.
We should go mark you tardy. So like really a ton of matters. I guess it does. You do get a grade.
You get a grade for which is just so dumb. It's like I'm paying to be here.
You guys are done?
Yep. Hey, Mr. Halkey, when you mark us tardy, how many points do we lose on attendance?
Okay, I'll show you the grade thing.
I was wondering when I was going to see that grade for the retake that I got.
It'll be on the grade report if it comes out tomorrow. It depends on what my busyness is today. I would like to get all the tests graded today, and then it will.
Curious if I did any better.
So if you look here under grades, This is the part that is important, is notice there's 192 tests. Well, right now there'll be 288 test points. Right now, there are 34 in-class points, and there are 122 my math lab points. So here's the situation. We get 1 point per hour for in-class. So over the course of the semester, there's 32 days times 2 hours is 64 points. So if absent is 0, tardy is 1, and present is 2 points. So the total number of points is 64. That's the most you can get at the end of the semester on that topic. But right now we've had 34 of those points already passed. So if you looked at the pie of the grade, I've got the percents down here. The percent of the grade that goes for tests is 60%, 10%, and 20%. So this is that part that comes from attendance altogether. You lose 1 point for tardy compared to 1 point for present. That's the bottom line. But what I'm trying to show you is those are not that big compared to the test. Like, for instance, today's test is worth 96 points, and there are 19 questions. So each question is worth 5.05 points, which is 2.5 days of coming to class. So getting 1 question wrong on the test is equivalent to missing 2.5 days of class. It's not, the test questions are way more important worth way more than the amount that you would gain through attendance points, or whatever they call them, participation points. Does that make sense?
So out of curiosity, how come you grade attendance?
That's a good question. When we adopted this curriculum, our boss made us grade on participation. Now, that being said, she can tell me what to do, but I can make exceptions. And the exception that I made is if your test score is higher than your regular score, I go by your test score. So for a lot of students, their grade is higher than what their this plan would go about. Like, for instance, if this plan said you had an 84, but this section right here was 95, your grade would be 95%, okay, which would be like an A. I'm not totally comfortable with it, but it's what my boss, actually, she's not even my boss. She's in charge of student services. She said that's the way we should do it. Now, the reason she said that is there's a lot of folks that don't do very well on tests, and so she wanted to have it so that those folks could recoup some of their grade by getting perfect attendance. And so the idea that she was saying was, well, this will help like raise folks' grades. And I said, that's not really true in the classes I teach. Showing up for class is important, right? We all agree with that. You learn stuff. But being able to produce results is way more important, and that's why I have that exception that says your grade is can be just on your tests. Okay? Now, I used to give a final test, and the way I did it when I had a final test was your grade in the course can be no lower than your grade on the final test, which I liked even better, because then everything is on one test, and you're like, well, if I do really well on this one test, I'll get a good grade in the class, which is what it is at the university. We have, at the university, you'll have one math test in the semester, and it'll be worth all the marbles. I don't know. Yeah, Jess.
So on my math lab, I can't see the scores of each of my tests.
Oh, each of your tests. Yeah, I didn't put them in.
Yeah, so I'm wondering where I could see those, because they're not in E360 either, so maybe you could just show me, because I'm just curious, what my grades look like for my tests.
Okay, on the grade report that I send out, I didn't think about that I don't have those listed there. They were listed after every single test. They were listed there, but I will put them on the next grade report that I send out.
Okay.
What your test score in 1 was, what your test score in 2 was, what your test score in 3 was.
Did I talk to you about
Thank
retaking
you.
that first test?
What?
I talked to you about retaking that first test, and you said you had to find a different version.
And I still have not found that different version yet.
Okay, because I would remember the original.
Mr.
Anyways,
Well, and that's what was that you that said that? Yeah, that my chance of remembering what the first test was is going to be negligible. Yeah, what's that?
Have you graded our retakes yet?
I have, and here's what I have found. Very seldom do people get a better score on their retest than they did on the original. And the reason for that is you got to remember that the original test had the group score included, and invariably the group score raises folks' grades by a lot.
Then could you show us our grades for that? Because
Yeah, that's what I just said, that I will include the 1 through test scores.
but also the retakes. That's what I'm asking.
I don't know if I can. I can add that column to the thing, but right now, that's one of the. That's not one of the choices
or at
on
least
here. I can add a column.
an email.
Test.
I'd be okay with just another email saying, "Hey, this is what you got." And I'd be like, "All right, sounds good."
Test 1 retest. Test 2 retest. Test 3 retest. Test. Oops. 4 retest. Yeah, I can see if I can get those in here. Let's see, equals. Oops, wrong direction.
Yeah, so I'm just having a little trouble understanding.
Test 1 retest. Sure. Test 2. Test 2 retest. Equals. Test 3 retest. Test 4.
Hold on.
Don't have a test 4 retest.
And if we do worse on the retake,
Yeah, I'll show you how that grade is computed.
okay, because I was just
So-
wondering if we did worse on the retake or just kept our original score.
So if you look here, take this person right here on test 1. On the regular test, they had a 58, which curved to a 70 But with the if at, they had a 68. So far, the 70 would have been the score that they got. But then they did the retest, and they got 100% on that. And so their score is that 100%. Remember, there's only 96 points. It's not 96%. They got 96 points on that first test.
So then if we do,
Take this person as an example down here. Okay, on the regular test, they got a 64. But then with the if at, that raised it to a 72. The curved score of a 64 is 73. So far, they had a 73. But then they did the retest. That was worth a 76. So if you notice here, here's how I figured out the math. I said, take the maximum of this number, this number, this number, this number. Take whatever one of those is the biggest. So if you had the biggest in this column, that's your score. If you had the biggest in this column, that's your score. If you had the biggest in this column, that's your score. Did you guys put your names at the top?
Of this? No.
Yeah, put them up there so that I remember who's in which group. So then if you go to like test 2, oops. Okay, here's the example. So, like for instance, the regular score is in this column over here. So then, this person, for example, got an 87.5 on the test, which curved to an 89%. And then with the if at, it was 89%, which is slightly high, 89.0625. It was slightly higher than 89%. So when you got to the score, that person's score was the maximum of those values. Look at this person right here. So on the regular test, they had a 75, curved to a 75.8. With the if at, had a 77.53. So then when they did the retake, they got a 71. Well, I'm not going to give them the 71. I'm going to give them the highest of whichever one of those they had, which for this person looks to be the if at 77%. Okay? So while you guys were gone, what they asked is, can you give me my test scores and my retest scores for all of the things? So I'll send that out when I send out the grade report today, because you can't see it in E360 and you can't see it in MyMathLab. Okay, so I'll just put them in that email that I send out.
will this test today be on the grade report tonight?
Pardon?
Will this test that we took today be on the grade report tonight?
See, that's a good question, because right now my day looks like it could be, like I will get it done. I have some work that I was supposed to do last night that I didn't get done yet, and so I'm trying to decide if giving you guys your grade report will be better, which I think is, because they're already, they had test 3 already, and so theirs would just be an update of homework and in class after that. The tests, as I was showing the group while you guys were gone, this is the way the score looks. Did you guys get everybody's name on your sheet too, Sam?
Yeah, I think so.
Okay. So this graph shows that the tests are worth 60%, the in-class is worth 10%, and the MyMathLab is worth 20%. That doesn't add up to 100. I must have missed something there. Let me check again.
I thought the MyMathLab was 30.
It might be 30. That's where I might have made the mistake. Oops, grades. Yeah, it's 30%. Sorry about that. So this part here should be 30%. Okay? So, the in-class is worth 1/6 of what the tests are worth. I was just telling them that each question on the test we just took was worth 5 points. Showing up today to take the test was worth 2 points. So if you got one question wrong, it's equivalent to missing 2.5 days of class. That'd be a way to look at it. Okay? Doing your My Math Lab, each one of those My Math Lab assignments is worth 1 point. There's enough of them so that it totals out to be 30% of your grade. There's like 180 of them. 188?
Yeah.
188 of them. So there are some folks that are getting every single question right on the My Math Lab. Okay? They go through it until they get every single question right on every single one of the assignments. Is that what you're saying? Poor Janae.
It's kind of awful.
It's kind of awful. Okay? So that's going to be that section of the pie there, the 30% section of the pie. So there's 188 points there. Each test is worth 96 points. So think about it that the My Math Lab is equivalent to doing 2 tests, half of the tests. Okay, yeah?
Are the previews counted in that score? Or is it
Yes,
only...
previews too.
Interesting. Okay.
Previews and assignments both are counted in that score. Now, here's the part that they were asking about. They said, well, Kevin, why are you grading on attendance? And I was telling them, my boss said when we adopted this way of teaching where we're working in groups, she said, well, there are some people that really, really like working in groups and they really, really have a big test anxiety. Okay? And I totally understand that. I was teaching high school calculus, and when we did groups, this one girl said, oh, this is the greatest thing in the world because I need other people to support me. And this guy says, oh, I hate groups because they just drag me down. Well, anyway, those two got married and they have 4 kids. So, it kind of shows you that you learn along the way. They married each other, I should say. So, my boss said, here's what you need to do. Well, here's the thing that she was thinking about that is not true about y'all. And that is, if you have test anxiety, you probably aren't going to go to the university. Okay, and this class is designed for folks that are going to the university. If you are going to go to the university, you're going to, at least by the time you graduate CBTC, have to be comfortable with the fact that there are going to be high-stakes tests that I won't have any control over. Okay? I just took a class at the university. We had 2 tests, 2 things of which we were graded on. So they had this high-stakes thing. Now, in my mind, is that one of my tests that I should take back, or what is that?
Yeah, that's
Okay. In my mind, it was kind of bogus because I got the highest score in the class, and I had like a 63%. It's like, well, that doesn't seem like that was a very good test. Okay. Well, the teacher had asked questions that were like impossible for a mere mortal to do. I don't know, like maybe that's all he did all day long was it was on figuring out how to make pixelated video or pictures into mathematical equations. So that's what we did, you know, JPEGs and all those kinds of things. That's what we were doing mathematically. Whatever. So I got like a 65%. So he graded it on a curve, which made my grade worth 100%, and then everybody else, like if you got a 30% on the test, you probably still got a C. I don't know. I wasn't in on how the other students felt about it. So that's one of the things that the university will do to help you out. I know that a lot of stuff is going through your mind, so let's talk about it. The university is going to be different than CBTC. It's not going to be harder, though, you guys, because there are going to be people there just exactly like you, all right? What you lack is confidence in your ability to succeed. You don't lack in skills, you just lack in confidence in your ability to succeed. And that's true for everybody. like I took those classes at the university and I was like, ooh, this is kind of scary. And I said, hold on. You've got your degree in mathematics, buddy. How tough can it be? Okay? And it wasn't. I mean, it's just, you just have to become comfortable with being able to do stuff that you know how to do. Okay? Now, when I was, any other stuff? We lost somebody in Menominee. Okay. Where are we? Oh, we were going to talk about that one question. So let's look at this question where we go from 10 to 11. So I'm gonna make my x-axis go from 9.9 to 11.1. And I'm going to make my y-axis go from negative 0.01 up to, say, 1.5. Okay, so there's our graph of that question number 2 where it says, what is the slope of 10 over x? Remember that question on the test? So here's the section that I wanted to talk about that we're doing, and that is, what is the value here at 11, which is the value at 11 is 10 over 11. The value at 10 is 10 over 10. Okay? 10 over 11 minus 10 over 10. Well, this is the same as 100 tenths. And this is the same as 11. Or no, let me think. 111. Or 110 tenths. So 100 minus 110 is negative 10 100 tenths over 11 minus 10, which is over 1. So that's the slope from this point to this point of the graph. Then it says, well, what's the slope from 10.5 to 11 on the graph? Well, if you look, 11 is still 10 over 11. 10.5 is 10 over 10.5. Well, this is the same as 100 over 105, right? Common denominator, and then over 11 minus 10.5. Common denominator of the 11 and 105. Uh, 1155. So this is 1,050 11/55 minus, let's see, 11/55. 100 times 11 is 1,100. 11/55 over 0.5. So if you look here, this is negative 50, 1155 or 55ths divided by 0.5. Negative 50, Negative 50 divided by 1155 divided by 0.5 is negative 0.08658. Up here, we have negative 10 divided by 110 is negative 0.0909. Okay, so you can see this one is closer to 0. Which, if you look at the graph, will also show you that. Yeah, anyway, that's where we are. Page 299. Half-life and decay models. In our graphs of functions, h of t equals 300 times 1/2 to the t over 6. Each one of these numbers means something. This number here is the beginning value. Zero, 300. This number here is our new divided by old, or our ratio. This number here is our time to ratio. So in other words, to get to 1/2, well, what's 1/2 of 300? 150. We are going to be at 150 at 6. So over 6, up 150. Does anybody know what over 12, how far we will be up? How did you figure that out?
Half of 150.
Very good. So you see how it's just going down by half each of these periods. So the next down by half would be over at 18. And at 18, how far would we be down? Half of 75, right? Okay, so let's look at what they're talking about here. For the remainder of this lesson, we will continue to work with the decay model given by h of t is 300 times 1/2 to the t over 6, which measures the amount of drug in a person in an individual's bloodstream t hours after taking a dose of 300 milligrams. Page 300. So let's fill out the table here. With each of these numbers. Now, some of them are going to be pretty easy. At 0, what will our answer be? So 0 will be 300. 2, 4, 6, 8, 10, 12. There are 2 more that will be easy to fill out. 6 will be 150, and 12 will be 75. Okay? Now, how do you find the rest of those numbers? Well, for this one, for 2, we're going to take 300 times, I'm going to write 0.5 to the 2 divided by 6. Or in other words, we're going to go 1/3 through a half-life. How much do we have left after 1/3 of a half-life? What does it say? 238. So fill out the rest of the chart there. And I'm going to take attendance while you do that. Nick, Michael,
Yep.
Marlena, Gavin, Janae, Felicia, Nicole, Eric,
Here.
Phil,
Yeah.
Grant, Connor. Connor? Oh yeah, he's here. Eric,
Present.
Laura, Madeline is gone today. Jess, Lauren, and Sam. Okay, so what did you get for your values on the table? 4? 189? 8?
119.
12? 10? Is that what everybody got? Everybody know how to do it at least. Okay. Now, let A of t be the average rate of change on the interval or for the function. So now we're going to do A as a function of t. But to do that, we not only need t, but we need the t for one more than each of those numbers. So I should have, on the chart above, let's make sure that we have each of the intermediary values. So what's the value of 1? What's the value of 3? What's the value of 5? 7, 9, 11. Let's find each of those values. So 300 times 0.5 to the 1 divided by 6 is 267. 300 times 0.5 to the 3 divided by 6 is 212. 300 times 0.5 to the 5 divided by 6 is 168. 300 times 0.5 to the 7 divided by 6 is 133. 300 times 0.5 to the 9 divided by 6 is 106. And then 300 times 0.5 to the 11 over 6 is 84. So how do we find the average rate of change? Remember, it's the new value minus the old value, so the new f of x, minus the old f of x, divided by whatever time they give you, plus 1, minus the time. Well, what happens if you take the time away from the time plus 1? Think about it this way. What's the difference between 4 hours and 3 hours? 1. What's the difference between 5 hours and 6 hours? 1. So in every case, do you agree the denominator is going to always be 1? And so our average rate of change function is just this numerator, f of the new value minus f of the old value. So in this first one, 267 minus 300 is negative 33. 212 minus 238 is negative 26. Do the rest of them and see what you get for answers. Yeah, I have the wrong number here. It should have been 75. I wrote down 70. That's where I got it wrong. Okay, so if we graph our function, it goes like this, right? As we go along. If we graph our slope at 0, we're down at negative 33. At 1, we're at negative 26, then negative 21, then negative 17, then negative 13, then negative 10. Where is our greatest average rate of change? Over on this end, right? Remember, since our function is going downhill, the greatest rate of change will be the least steep part, the one that's closest to 0. Page 301. What is the function a of t? Well, it can't be linear, because if it's linear, each one of these numbers would be the same, right? It can't be quadratic. Well, let's go through why it can't be quadratic. What is the rate of change between here and here? It looks like it went up. What is that, 7? Right? Then it went up 5, then it went up 4, then it went up 4. Oops. You can't go up the same amount in 2 consecutive places for a quadratic function. So it's not quadratic. It is indeed exponential. How do you know? Well, let's do the math to show that it's exponential. On your calculator, you would press. So we want the new divided by the old. Negative 33 divided by, I'm just clear, negative 26 divided by negative 33 is 0.787. Negative 21 divided by negative 26 is 0.807. Negative 17 divided by negative 21 is 0.810. Negative 13 divided by negative 17 is 0.76. Negative 10 divided by negative 13, 0.76. Negative 9 divided by negative 10 is 0.9. So if you notice, each one of these is approximately the same. And the reason it's just approximately the same is that way back here, we rounded these, which made this rounded, which obviously is going to make your decimal rounded also. So those ratios are the same in an exponential function. Page 303. A researcher has been studying the growth of cancerous cells in a tumor. F of t equals 20 times 2 to the t over 170. This model is growth. Can anybody tell me from the equation what tells us that the cancer is growing in the equation itself?
Positive slope.
Yes, it will have a positive slope, but from the equation, yeah, Sam.
Isn't it as the time goes on, you're going to get a larger and larger number?
Very good. And the reason for that is growth is related to this number right here. If that number is greater than 1, it's growth. If it's between 0 and 1, it's decay. So if you look back at this formula here, we could have told it was decay because this number right here is less than 1. Therefore, it's decay. Let's go through the rest of the values that this equation tells us. The 20. Look back.
It's the number of cancerous cells.
Okay, so it's 0, 20, or the y-intercept, or the initial value. So this number here translates to this number here. The 2 is the ratio new divided by the old. So the new value is going to be twice as big as the old value. So we're going to go along here, and if we were at 20 here, at some point we're going to be at twice 20, 40. Where is that point? Time to ratio. So to double takes us how far over? 170 days. So our graph is going to go like this. We will have doubled by 170 days. By 340 days, we will be up to how many cells? How many? 80. Got it? Page. 304. Determine a formula. So now we're going to do the formula for the average rate of change. Now remember, if they're going from t to 1 plus t, there is no denominator. So we're going to take the f of the t plus 1 value, subtract the f of the t value. Well, our formula says 20 times 2 to the t plus 1 over 170. And we're going to subtract from that 20 times 2 to the t over 170. So to do this, they have a table that says t, f of t, and a of t. We're going to modify the table because we need to know not just what the value is at 1 or at 0, but also what it is at 1. Not just at 20, but what it is at 21. not just at 40, but what it is at 41, not just at 60, but what it is at 61. Well, they tell us it starts out at 20, then at 20, it's 21.6993. At 40, it's 23.5429. And at 60, it's 25.542. So it looks like they wanted us to give 4 decimal places each time. So let's do what is the value at 1. So we take 20 times 2 to the 1 divided by 170. And we get 20.0817. So our A of t for this first one will be 20.0817 minus 20, which is 0.0817. Okay, so let's do the next ones also. So our value at 21 will be 20 times 2 to the 21 divided by 170. 21.7879. 41. 20 times 2 to the 41 divided by 170 is 23.6391. And then last one, 20 times 2 to the 61 divided by 170 is 25.6476. So now when we do the subtractions, here we'll take 21.7879 minus 21.6993. Here we'll take 23.6391 minus 23.5429. Here we'll take 25.6476 minus 25.542. So fill in those values, and we'll see you next time. Yeah.
Weight.
Let's see here. Which, here we go. This one right here.
Yeah, because we're just supposed to plug in like R and R and then to 0.
Starts out at 0, but eventually it goes to infinity. If a person weighs 180 at sea level, what value will her weight approach if she starts moving indefinitely away from the Earth? So in other words, this is going to go to infinity plus the radius. So if you take a number, let's do the math. 3959 times 180 divided by infinity plus 3 9.